What is going on, guys? Welcome to another video in my tutorial series for digital logic. Now today we're going to be talking about decoders. Alright, now what a decoder is basically the exact opposite of an encoder. A decoder takes a decoder takes n inputs and it returns 2 to the n output. However, only one of which will be set. Alright, let me go ahead and draw a little diagram here. So if we had 2 inputs, we would have a 2 to the n outputs, which gives us 4, and only one of which can be set at any point in time. Now, let me explain the functionality of a decoder here. So if we had a 2 input 4 output decoder, what this would mean is we would try to translate or return a binary input into its decimal notation. Okay? So if our inputs here, for instance, if I call it D0, D1, now if these two were set to 0, aka the binary value of 0, we would want this to be set. Now if these were set to, say, 1, 1, we would want the value of 3 to be set, because 1, 1, and this being the least significant bit here, 1, 1 would equate to the value of 3 in decimal notation. Okay? So that is what a decoder is used for, and I'm going to go ahead and draw a truth table for that. You know, I should have left this up here. No worries. D0, D1. And I'm going to call my outputs Y. So Y0, Y1, Y2, Y3. Alright, so inputs here. D0, D1, D2, D3. Sorry about that. D0, D1. Now outputs. Y0, Y1, Y2, Y3. Alright. Now remember, so first thing we gotta do is put in all possible inputs for our D values here. So 0, 0. And these correspond to the binary representation of this. Also, one thing I do want to switch is, why don't I go ahead and do this? I am going to label this D1 and label this D0. Okay? The next thing we want to do is label the corresponding outputs. Alright, and as I've mentioned before, when D0 and D1 is set to 0, aka the binary representation of 0, we want the first value to be set, which corresponds to the decimal value of 0. So when the binary value is 0, we want the decimal representation of 0. Now if D1 is set, we want the binary representation of this to translate to its decimal representation. So we would have 0, 1, 0, 0. Okay, so this would be set. Alright, so let's continue. So we'd have 0, 0, 1, 0, 0, 0, 0, 1. And that is the truth table for our encoder right here, for our 2 to 4 encoder. Alright, 2 input, 4 output. So how would we go about drawing this on the lowest level with gates? Now, it's going to be comprised, the way we achieve this sort of effect where we only have one output set at any given time is through the use of AND gates. Alright, so why don't we go ahead and draw our inputs here. We have D0, D1. Ugh, sorry about that. We're gonna have 4 AND gates. One for each one for each output. So Y0, Y1, Y2, Y3. Sorry about all the coughing. I just have a really scratchy throat, you know. Now, when D0 and D1 is equals to the value of 0, so let's see, the way we're gonna do this, connect these to all these 4 AND gates, is through the use of, how am I gonna draw this? Okay, our NOT gates here. Okay, now, how are we gonna do this? Okay, so when D0 is, when Y0 is set, D0 and D1 is set to 0. So D0 is set to 0, so we connect it to the NOT gate, and D1 is set to 0, so we connect this here as well. Alright, now when D0 is set, when Y1 is set, D0 is going to be set to 1. So when we do that, D0 is going to be set to 1. And D1 is going to be set to 0. So D1 is going to be set to 0. And that is how we do that. Alright, now on to the next one. When Y0 is set to, Y2 is set to 1, D0 is set to 0. So we're going to go ahead and do that. Connect it right there. And D1 is going to be set to 1. Right there. Now lastly, when Y3 is set to 1, our output is set to 1, D0 is going to have the value of 1, and so is D1. So we're going to connect it right there. And there's that. Alright, now that looks a little messy, but I'm sure you guys can draw this a lot better than I can. So just remember, base it off the truth table and you will be just fine. Now, thank you guys for watching this video. Again, sorry for all the little distractions in this video because it's really late at night. And yeah, it's pretty late at night. So, well, thanks again for watching this video. If you like this video, please give me a thumbs up. And I will see you guys in the next video.